Good evening, everyone. I'm Abhishek Bhave. I'm from Thermax. We are in energy and environment segment and working on clean energy, clean air, and clean water. I know we are running short of time, so I will quickly wrap the presentation. It will not take too long, but I want to share two concepts with all of you today because I think that it's a thing which everybody should also look at when, especially when India is looking at multiple options in waste management, because we are trying too many things at the same time. So it is likely that few things will succeed quickly. It doesn't mean that the other things are not successful. They will shortfall. There will be a shortfall, but they will catch up. So predominantly, I'll skip all this part, what we are focusing and all. But I want to share with all of you that this concept is something which we are working on in Thermax, where we are strongly believing in three aspects. One is sustainability. So how you get it? You get it by maximizing the renewables. Second is decarbonization. How you do the decarbonization? Basically by having hybrid systems, which means that there is no single solution for waste management. You have to have waste to energy plants that run on incineration model. You have to have gasifiers. You have to have things which convert waste into some other fuel like oil or hydrogen. You have to have all of this together. If you are betting only on one, it is not likely to work, because India is looking to leapfrog. We are doing things in a very quick way. If you look at the Western world, they have been doing these things for 100 years, and we are working only for last 10-20 years, maybe out of that only 5 to 10 years more seriously in this field. And when we are doing all this, viability is also very important, because if something is not economically viable, it is having a less chance to become sustainable in our country. So I'll skip all this part, but we have to understand that energy, because waste is basically getting converted into wealth through energy. So we have to understand that how in the country the fuel sourcing has been changing for steam and power basically. And for that, when you look at fuel sourcing has been driven predominantly by cost, availability, environment impact, and what you call as the waste disposal. So this has been the prime concern area when we are sourcing fuel. And when somebody is looking at equipment design, what we are looking for is really reliability, availability, efficiency, and we also want flexibility. So what we have seen in past few years or maybe months, that the fuel is changing in a big way in the energy transition journey, and we are getting geared up for coming out with equipments that can take multiple fuels at a time, because we cannot have only municipal solid waste fired equipment, and then if that waste is not available, if some other biomass like rice straw or parali is available, can that be also going in that boiler? So we are trying to develop hybrid systems so that the customers can have the flexibility in choosing the fuel which is available in their locality. This is very important aspect on which we are working. Going forward, I will skip this part, what we are offering in waste to energy, because right now I don't want to spend time on that. But we are working on many things. We are also working on these are the boilers which we are supplying, but we are also working on bio CNG, where we are converting the wet waste into biogas and then cleaning it to bio CNG level, where we increase the methane percentage to more than 90%. And we are also working on waste to hydrogen. We are also working on biomass to hydrogen also. But as I said, we are working on all these three things because we feel that all these three things have to be focused at the same time. Going ahead, this is one more perspective which I wanted to share with everyone. What we are actually doing here is converting waste into fuel. When we do that in two steps actually, because that fuel is also going to get used somewhere, either in engines, either in boiler, or somewhere in the vehicles. So predominantly what we are doing is we are increasing the carbon footprint in some way or the other, because you are converting waste into a fuel and then again using that fuel to fire something else, right? So we have to look at the total life cycle of the carbon footprint, because just by converting waste into fuel, of course it is required because it makes the combustion part cleaner. Yes, there are advantages. As you rightly said, there are advantages. But we have to also look at a total, what I can say, the life cycle of the carbon footprint. And that's where we are currently working on, because when you go to a decentralized level, these are the questions which we are asking, that whether it can become more, it can become a single step. Can we help our customers to reduce the overall carbon footprint? Can we achieve solid discharge which is completely zero for our customers? So that means we work on a decentralized model as well, along with the centralized model. And then again, I am coming back that there is no one solution. We have to have centralized models, we have to have decentralized models. Everything has to complement each other, and only then we can really solve the waste management problem. So our focus is more on developing all the solutions which are more sustainable, economical, and at the same time we are able to decarbonize our customers' carbon footprint as well. So I wanted to share an interesting case study. This is a waste which we are burning, combusting in one of the boilers which we have supplied in Dahej in Gujarat. This is a recycling paper plant where they are importing waste. This waste predominantly consists of non-recyclable solid waste. There are many non-recyclable plastic fractions, there are polymers, and this type of waste was getting incinerated in cement kilns. And there was no control over it because there is no gas cleaning systems on the downstream of it. So predominantly you're just creating a environmental hazard, and more than that, waste handling is a cost to the client, and it is also increasing the waste footprint because Gujarat waste is going in Rajasthan. So you can imagine the carbon footprint of the vehicular CO2. So what we did is we set up a plant, okay, and this is the first plant in the country which is running commercial operation for 3 years. This is also audited by NIRI from Nagpur, and this plant is able to showcase. This is combusting about 100 tons per day as the first plant, and it is having a complete flue gas cleaning system, incineration system, and it is able to meet all the solid waste management norms in the country, emission norms. Much even it is beyond what is required. It is almost close to European norms, and we are able to reach steam to fuel ratio of more than 4, which is incredible. This is almost close to any biomass or coal fired boiler. Second is, look at the unburned carbon loss, it is less than 1%. So we are recovering complete carbon here. We are also able to get good efficiency, and at the same time we are able to meet 20 emission parameters. Okay, not just SOx, NOx, particulate matter, but there are 20 parameters which we are complying to. So this makes this a very interesting solution. We are offering this solution to many paper mills in the country now. We have also launched one more product which is called as Flexi Source. As I said, we are working on hybrid systems which can combust at a time 10 different varieties of fuel. So you can have municipal solid waste or a refuse derived fuel coming in the same boiler. You can have rice straw in the same boiler. You can have rice husk. So basically, the customer and the adjoining locality can supply the fuel to the customer, and the customer is not required to go, or the user or the developer is not required to go to different places and bring the fuel, because that also increases the carbon footprint. So that is our whole idea, that we source the fuel from local areas so that we reduce the overall carbon footprint. And you should have a hybrid equipment in place to combust such type of fuels, because it is not easy fuel to burn. So there are very advanced combustion systems. We have tied up with many companies. We are also bringing technology from Europe. We have a license from Stan Muller, and we are also working on many digital platforms where we are trying to do automated combustion. 6 different zones of combustion, completely automated, controlled through DCS with automatic combustion control loop. So the idea here was to share that what impact is created from this one single plant. So you can see that we are able to almost have 33,000 tons of waste saved, okay, because it is not going to any landfill, or it is not going to incineration plants or rotary kilns without environmental hazards, okay. It is going to a plant which is completely sophisticated and meeting to all the emission norms. Second, we are able to reduce the waste volume to 95%. Third, we are able to save 21,000 tons of coal, which this client would have anyway fired to meet his power requirements and meet the steam requirements. So this amount of coal is not required anymore. We are able to reduce CO2. So about 50,000 tons of CO2 is saved. These are all annual numbers. We are able to meet more than 20 emission parameters in the plant, okay. And more importantly, the customer is getting about 1.5 megawatt power output, which they were taking from grid. So the waste which is within the plant is getting used in the same plant to generate power and meet the steam and power demands of the customer. So this is where I wanted to share an example that we can make such kind of decentralized models as well, when we are focusing only on the central models where we are working on big plants and big facilities. Such integrated waste management facilities is required for big cities and urban cities like Delhi and Mumbai and Kolkata and all big cities. But at the same time, we have to also focus on the industrial sectors, on the decentralized models, where we can take out the waste which is away from the city and use it within the same premise, so that we create a circular economy around those plants and industrial sectors. So this is what I wanted to share with all of you. I hope that it was interesting to you. Thank you. Thank you very much. We are currently doing this in Uttarakhand. There is one plant coming up in Kashipur. There are a couple of plants coming in Muzaffarnagar. There are few plants coming in Meerut. So we are on the way. Bottom ash is clean because it is coming from the waste which is getting combusted. It is completely clean. So only thing is you have to separate the metal part of it, because there are few metals which will come in the waste. It is not hazardous. The fly ash is hazardous because it contains pollutants which are trapped.
Thank you, Dr. Bhave. Now interaction can be done anytime.
Right.
Tea and sweet.
Sure. Thank you.